Hello everyone, so welcome to my trigonometric integration video series. But before we learn how to solve trigonometric integrals, we want to learn about identities. Now, probably you already know these identities, but we want to learn how do we use these identities and when to use these identities, because the hardest part in trigonometric integration is to decide which identity to use and how to manipulate them. Okay, so usually people don't do this, don't spend time on learning about identities. Now, if we spend time on these identities, we can learn their special characteristics, unique things that they have, so it helps us to decide which identity to use on a given integral problem. Okay, all right, so let's start this discussion. We are going to have these discussions for 2 videos, but in this video we're going to discuss about Pythagorean identities. Now, I know Pythagorean identity is very easy, but because of that, don't click out of this video, because we are going to learn 2 important things about Pythagorean identities. Okay, so the Pythagorean identity is very simple. Sine square x plus cosine square x is equal to 1, and you can take this cosine square to the right hand side and write sine square x is equal to 1 minus cosine square. Similarly, if you take sine square to the right hand side, we can write, well, cosine square is equal to 1 minus sine square. Well, you already know this. Now, how do we use Pythagorean identities? What is the advantage? What is the use of Pythagorean identities? Well, if you look at these 2 statements, these are the 2 statements that we are going to use. Okay, the way we use Pythagorean identity is, if you have a sine square, you can replace it by 1 minus cosine square. Well, if you have cosine square, you can replace it by 1 minus sine square. Now, why would I do that at first place? Now, sine square x is just a one single term. If you compare sine square x with 1 minus cosine square x, 1 minus cosine square is a little complicated than sine square x, right? But looks complicated. Actually, it's not. So why we do this? Well, let's say you have given a function sine square x times cosine square x. Now, the use of Pythagorean identity in the context of trigonometric integration is that, let's say you want to write this function just in terms of cosine. Now, if you look at this function, it's a mix of both sine and cosine functions. But what if I want it to be only made out of cosine? Well, I can replace sine square x by 1 minus cosine square x, right? And then we get this. Now, this function is, everything is cosine, right? Now, let's say you want to write the same function. I don't like cosine. Let's say you want to write it in terms of sine. Well, we can keep this sine square and replace cosine square by 1 minus sine square. So that is how we use Pythagorean identity. Okay, in the context of trigonometric integration. Now, Pythagorean identity helps us to write a given function either only in terms of sine or either only in terms of cosine. Okay, all right, that's one fact. Now, another fact that often students forget or never understand is, well, it's obvious fact, but you don't spend time to observe it. If you look at these 2 identities, okay, they are the same identity written in different way. If you look at the power of the trigonometric function, here on the left hand side you have sine square, but on the right hand side also you have power square, cosine square, right? Power 2. So Pythagorean identity maintains that power. Okay, or the better way to put it is that it does not reduce the power of the trigonometric function, which is a very important thing. You will not understand the importance of that until we learn other identities. So let's say something like this. Let's say you really hate sine square, okay, but you like cosine, but you don't want any trigonometric function to be a power other than 1. We can't use Pythagorean identity to do any adjustment, right? Because Pythagorean identity will always gives you a power square, even though you trade sine and cosine between. If you switch between sine and cosine, that's an important thing. You can't reduce the power using Pythagorean identity. Okay, all right, so let's do some problems using Pythagorean identity. Okay, so here we have sine times cosine square. Now they say write fx only in terms of sine. Well, instead of cosine square, I can replace 1 minus sine square. Very easy, right? Now you don't need to simplify this, okay? I don't expect you to simplify that. All right, so let's do some exercise. Now in the question says write the first two functions only in terms of sine. So let's see. First function, we have sine cube times cosine square. Now it's easy, right? This will be like sine cube x 1 minus sine square x. I replace cosine square by 1 minus sine square. Very easy. How about second one? You want to write everything in terms of sine, so you need to get rid of cosine to the power 4. Now that's the important thing. Now we know Pythagorean identity. If you want to convert cosine to sine, we know cosine square x is 1 minus sine square x. But does that mean cosine to the power 4, it's 1 minus sine to the power 4? No, right? No, it is wrong. How do we get cosine to the power 4 using this identity here? Well, if you want to get cosine to the power 4, you have to square this, right? So that means you have to square the whole thing, all right? So cosine to the power 4 is 1 minus sine square x to the square. Now you don't need to simplify this for now, but that's it is, okay? Understand what I'm trying to say. Don't do that mistake. Don't just change the power here and say call it good, okay? So second function is sine cube x times cosine to the 4 is actually 1 minus sine square x to the square, right? So remember that. That's super important, okay? All right, here we have sine square cosine cube. So and last two function in terms of only cosine x. So we want to write these last two functions only in terms of cosine. So how do we do that? Really quick. So we have sine square, we want to write it as cosine, so it's sine square is 1 minus cosine square x times cosine cube x, okay? All right, so we are done. Fourth function is sine to the 4 times cosine square. You want to write this function just in terms of cosine. So sine square x is from Pythagorean identity 1 minus cosine square x, right? What is sine to the 4th? Well, sine to the 4th is actually 1 minus cosine square x to the square, okay? Be careful there. All right, we discussed this already. So if you want to write this function in terms of just cosine, it will be 1 minus cosine square x to the square times cosine square x. Now I don't expect you to simplify this, okay? Actually, we don't need to simplify. That's the beauty of trigonometric integration. When we learn integration, you will see more. All right, so just to finish it up, just to summarize, what is the use of Pythagorean identity? Okay, we use Pythagorean identity either to write a function just in terms of sine, or either to write a function just in terms of cosine. Now I'm restricted to trigonometric integration, okay? I'm not talking about any trigonometric problem, okay? We are just building up to trigonometric integration. The other thing you want to carefully remember is that Pythagorean identities does not help you to reduce power, okay? The power is square, it stays the same, okay? It does not reduce the power. You will understand what I say more in the next video. So hopefully I'll catch you in the next video. All right. Thank you very much for watching this video. Bye bye.